All right, in this video, we're going to tackle the problem of differentiating a quotient of functions. In our last one, we looked at the big question of how we differentiate a product of functions, and that worked out pretty well. We're going to do the same kind of thing for quotients, except we have some advantages here. We likely know, or at least believe, that if we're looking at the derivative of some quotient of functions like this, that's probably not going to be f prime of x over g prime of x. That didn't work for products, and so it makes sense that it's not going to work for quotients, although this is a pretty common mistake that students will still make. Instead, what we're going to do is we're going to take the product rule and we're going to shuffle it around to get the quotient rule out of it. Then we'll take a look at some examples. So here's our general strategy. Remember the product rule. The derivative of a product of functions is the derivative of f times g plus f times the derivative of g, and you can shuffle that up into whatever order you'd like, as long as you really do have f prime and g in the same term and f and g prime in the same term. What we're going to do is take a look at the derivative of this quotient here by setting q of x, for quotient, equal to f over g, and then we're going to rewrite this as a product. So let's get this going. Here's the quotient rule. For functions f and g that are both differentiable at x, consider this quotient q of x, f of x over g of x. Our goal is to find the derivative of q, and specifically we want to have it written in terms of the parts, f and g, and possibly their derivatives. So we're expecting to see some f's, g's, f primes, and g primes in the rule for q prime of x. I had said we were going to rewrite this as a product, and this is what I mean. We can rewrite this equation here by just multiplying g of x on both sides. And now what we're going to do is find f prime of x using the product rule. So we can go ahead and say u is equal to q of x and v is equal to g of x. Suddenly u prime is just q prime of x. We don't really know what it is. It's the derivative of that thing. And v prime is same thing, kind of idea. It's g prime of x. It's just the derivative of this g function. Then we can use our product rule to do this nice little crisscross thing where we put those terms together. And here we go. F prime of x is really q of x times g prime of x plus q prime of x times g of x. And hey, look at that. Our goal was to find q prime of x. There it is. Right there. We got it. So what we have to do now is solve for q prime of x. That shouldn't be too hard though, because we can just subtract q of x, g prime of x from both sides, and then divide g of x. I'll give you a second if you want to just scratch that on a piece of paper, but this is what you're going to end up with. So double check this just to make sure you can follow the algebra. All we're doing is solving for q prime of x because that was the thing that we really cared about. And there we go, quotient rule, done. Except we're not, because look at this. We wanted, remember in our original goal, we wanted this derivative to be written in terms of f's, g's, f primes, and g primes. And here we have this q of x. That's not too big of a deal because we know that q of x is equal to f of x over g of x. That's what we said right at the beginning. We defined that quotient as f over g. So let's just go ahead and put it in place. So really, q prime of x is equal to f prime of x minus f of x over g of x times g prime of x over g of x. All I've done is just tossed this fraction in place of q. Now what we can do is simplify this fraction, just clean it up a little bit by trying to clear out this denominator, this g of x. Let's just multiply g of x on the top and on the bottom here. Really, we're just multiplying by 1, right? So this should be fine. We have to do the distributive property on the top. In our numerator, we now have f prime of x, g of x, minus, notice this denominator goes away, so we have f of x, g prime of x, and then in the denominator we have g of x squared. And this is our quotient rule. So here we have it. If f and g are both differentiable at x, then the derivative of f of x over g of x is f prime g minus f g prime over g squared. And we have one little caveat. Don't let the denominator be 0. That should make a little bit of sense. We know that if the denominator is 0, then this function isn't actually even differentiable there. Just like the product rule, we can rewrite this with u's and v's. And so sometimes we rewrite it this way, vu prime minus uv prime over v squared. This is an annoying rule for a couple of reasons. The product rule is pretty nice because the order doesn't really matter. It's all addition and multiplication, meaning you can just jumble up all the terms, and as long as you have one function with the other derivative, that's fine. With the quotient rule, though, we have this subtraction here. So we really do need to make sure that things stay in the right order, because if we switch the order of this, we're going to get the opposite sign, right? 2 minus 7 and 7 minus 2 are related to each other, but they're opposites. One of them is negative 5 and one of them is positive 5. Whereas with addition, we don't have that problem. 3 plus 4 and 4 plus 3 are the same. They're both 7. Doesn't matter what order we add that in. So there are a couple of little mnemonic devices for remembering the quotient rule. I'll let you find all those things and figure this thing out, but you're going to have to eventually just commit this thing to memory here. All right, let's go ahead then and actually use it in some examples. I've got a couple of these. Labeling the parts for the quotient rule is pretty easy because the order actually matters. Remember, up here, we said that V, or if you want G or whatever other letter you're calling it, that's got to be the denominator. So we're going to say, all right, U is equal to x squared plus 1, and V is equal to x squared. Now we can find U prime, that's 2x, and V prime is also 2x. And I'll just write out the quotient rule here so we start remembering it. We're going to do V U prime minus U V prime all over V squared. Let's start chugging all that stuff in. We have VU prime, that's these two things first, 2x times x squared, minus UV prime, 2x times x squared plus 1, all over V squared. So that's x squared squared. I can do my multiplication now, and I've got 2x times x squared, that's going to be 2x cubed, minus 2x cubed minus, I'm doing the distributive property here, 2x all over x to the 4. And now we can just do some simplification. That's negative 2x over x to the 4. Obviously, our 2x cubed minus 2x cubed add up to 0. And then we can reduce this and say this is really just negative 2 over x cubed. Cool. There's our quotient rule. What you can notice is that you don't even have to do the quotient rule on this. If you want, you could rewrite this thing. You could say this is really the derivative of, we can notice this nice little upside down triangle shape, and split this fraction up. X squared over x squared plus 1 over x squared. Notice I'm splitting this into two pieces, two terms with a common denominator. And suddenly, this is really just the derivative of 1 plus x to the negative 2. And this is easy now. 1 is a constant, so that term is going to be 0. And x to the negative 2, that's a power function, so that's going to be negative 2x to the negative 3. And isn't that exactly what we had here? So be careful. Just because you have a function that's written as a fraction of two functions, you can sometimes double check and see if you can get around that division. In this one, we absolutely can use a couple little algebra tricks to just rewrite this. All right, let's take a look at one where we actually do have to use the quotient rule. Give this one a shot. Notice it's got all the same pieces. They're in a different order, though. As that first example, U prime and V prime are both 2x. Go ahead and fill out the quotient rule. Make sure that you can see how things get put together, and that should go pretty well. Go ahead and pause the video just to make sure that you've got some time. All right, let's do this. So VU prime, 2x times x squared plus 1 minus UV prime, 2x times x squared, all over V squared, x squared plus 1 squared. This is going to be 2x cubed plus 2x minus 2x cubed over x squared plus 1 squared. My 2x cubed and 2x cubed subtract off to 0 again, and so I have 2x over x squared plus 1 squared. If you wanted, you can multiply that denominator out. That's x to the 4 plus 2x squared plus 1. But I actually end up preferring looking at the ones with factored denominators still. That way, if I do randomly get a factor of x squared plus 1 in the numerator, I can notice that I'll cancel it. So I rarely actually multiply out the denominator. Hopefully that's something that is helpful, though. All right, give this one a shot, pause the video, and then when you come back, we'll just talk through it and see how it goes. This is our last example for this video, so try and do this one as much as you can on your own. All right, if you're back, then let's just go ahead and set it up. And then if you want to keep trying it, you absolutely can. So these are your pieces. So we've got v u prime minus u v prime over v squared. Go ahead and plug everything in there and see what you can get. If you need to pause it again, feel free. Okay, let's fill it all out. X plus 8 times 1 minus x minus 1 times 1. That's these pieces here. All over x plus 8 squared. So this is x plus 8 minus x plus 1 all over x plus 8 squared. That's going to be 9 over x plus 8 squared. And I'd probably just leave it like that, although again, you can multiply that denominator out if you'd like. So this is going to be 16x plus 64? Yeah, 8 times 8 is 64. So that's what we've got. All right, so that's the quotient rule. You'll notice that as we start learning more and more function types, we can put them in here as well. We could already go ahead and put some exponential functions in the numerators and denominators of these things. But in our next video, what we'll do is we're going to start looking at some derivatives of trigonometric functions. And so hopefully that will be helpful to see as well. We can eventually include those into our product and quotient rules too.